Okay, y'all, today we're going to talk about, for the very first time, we're finally going to solve quadratic equations. And we're going to talk about solving them when they are in standard form. And standard form looks like ax squared plus bx plus c equals 0. And we're going to talk about first when a is equal to 1. Alright, now to solve a quadratic equation means we're going to find the places where the graph crosses the x-axis. Or another way to think about it is where y is equal to 0. Now the solutions are called several things, and we've talked about this before. Okay, they're called the roots of the equation, they're called the zeros, or they're called just the solutions. Sometimes they're called the x-intercepts. Okay, and one way, and this is a quick way to solve sometimes, and that is just to graph. Alright, if we graph it, we can sometimes solve by checking to see where it's crossing the x-axis. And if you look right here, we have two solutions, two rational roots. Okay, you can actually see that the graph is crossing here at -2 and +3. If you look at this example, it's crossing at, let's see, -1, -2, -3, -4. And it's not crossing, but it's just tangent to the x-axis at -4. So this is an example of a double root. Okay, just a rational double root. Now here you can see where it's crossing not on one of the cross points, but in between them. And so it's an example of irrational roots. And here's an example of where you have no real root. This is an example of a complex or an imaginary root, and we'll eventually get to that point. Now, the first way that we always learn to solve a quadratic is by factoring, and by far it's probably the easiest way to solve. Okay, when we factor, we're getting linear factors, and those are also called the binomial factors. Once we factor and get the binomials, we set them equal to 0. Now, we can tell where the parabola crosses the x-axis after we set them equal to 0 and solve. Now, before we actually start to factor, okay, what I want you guys to do is practice just factoring, just doing some arithmetic, looking at factor pairs. For example, let's just look at 36. What are all the factor pairs of 36? We've got 1 and 36, 2 and 18, 3 and 12, 4 and 9. What about even 6 and 6? And couldn't we even look at like all of these being negative, because -1 times -36 is still 36. So we could have even both of these factors be negative and get positive 36 when we multiply them together. Now, if one or the other is a negative number, then we get a negative. Our product would be -36 if just one of these was negative. So let's look at, if we have these as our factors, how could we like have these as factors but then add them to get a sum of 20 or a sum of -13 or 35 or -9? So out of these factors, which of them would add up to 20? Exactly, 2 and 18. Okay, what about out of these factors? Which ones would add up to -13? 4 and 9. We could do -4 and -9. Those would multiply to get 36, but they would add up to -13. Okay, what about 35? Could we do -1 and +36? Now those would add up to 35, but they would multiply to negative 36, right? And then what about negative 9? Could we do negative 12 and positive 3? Okay, well, here's the objective. Let's say that we want to factor, and I'll give you an example of a quadratic. Let's say we want to factor x squared plus 20x plus 36. What we do when a is 1, and our a is 1 here, we look for factors of c that add up to b. Okay, factors of c that add up to b. So we're looking at factors of 36 that will add up to 20. And in our case, that would be 2 and 18. So our factors of x squared plus 20x plus 36, our binomial factors, would be x plus 2 times x plus 18. And it's that simple. Okay, so let's look at this next example. Okay, we have x squared plus 6x plus 9, and we want to look at factors of 9 that add up to 6. Okay, those would be what, 3 and 3? So this would factor into x plus 3 times x plus 3. And y'all, this is one we've done before. We could actually write that as x plus 3 squared, because this is a perfect square trinomial, and we could write it as a perfect square. Now, to solve this equation, we're going to set the factors equal to 0 and solve. Subtract the 3 from both sides, and we get x is equal to negative 3. So there's our double root in this case. Okay, we only have one root, and this one would be negative 3. Now let's look at another example. Okay, we have x squared minus 3x minus 10 equals 0. Can you think of factors of negative 10 that would add up to negative 3? Okay, 1 and 10, 2 and 5. Oh, we could do negative 5 and positive 2. And so our factors would be x minus 5 times x plus 2 equals 0. Now, we'll set the two factors equal to 0 and solve for x. Okay, add 5 to both sides on this one, and we get x is equal to 5. And if we were to plug in 5 right there, that would make this factor equal to 0, and therefore the entire function would equal 0. And on this factor, if we subtract 2 from both sides, we get x would be negative 2, and if we plugged in negative 2 here, it would make this factor equal to 0 and make the entire function equal to 0. So this is where this function would cross the x-axis. Now let's do one more example. X squared minus 6x plus 8. So let's do factors of 8 that add up to 6. Okay, factors of 8 are 1 and 8, 2 and 4. Oop, it's got to be, well, let's see, we got to get negative 6 when we add these together. So if we do negative 2 and negative 4, when we multiply those, we'd get positive 8, and when we add them, we would get the negative 6 in the middle. So let's make this be x minus 2 times x minus 4 equals 0. And now to solve, we set the two factors equal to 0 and solve each one separately. So when x is 2, our function would equal 0, and when x is 4, it would also equal 0. And so these are our zeros, or our roots of this function. Now, if you're not sure if these are actually factors, we could always go back and multiply these out. Okay, in fact, I'll do that on this one just to prove that x minus 5 times x plus 2 is actually a factor of x squared minus 3x minus 10. Okay, I'm just going to FOIL it. So x times x is x squared. X times negative 5 is negative 5x. 2 times x is 2x. And then 2 times negative 5 is negative 10. And when we add up the like terms here in the middle, we get x squared minus 3x minus 10. Okay, we will look at factoring quadratics where a is not 1 shortly. Okay, but I want you guys to practice just factoring when a is 1. It's fairly easy, and if you have any questions, just watch this video over again. Have a great weekend.